Today we're going to look some more at absolute value functions. We're going to take a look at a graph, and given that graph, we are going to write the equation. So we did this with parabolas. Now we're going to do it with the absolute values. So we're going to write the equation if we look at the graph. Okay, and there's a lot of logic involved with this, and it's going to be very similar to what we did with quadratics. This is the basic form of the absolute value function. And again, it should look very similar to what we did with quadratics. So we have our k value here, remember, which is a shift up and down. Inside the absolute value, this is going to be our left and right movement. Again, it's backwards, right? It's opposite of what you would think. So if it's a positive, you're moving left. If it's a negative, you're moving right. With our a value here, this is going to tell us whether it's skinnier or wider. It's also going to tell us whether it opens up or opens down. Okay, so that's our scale, what we are calling our scale in parabolas. So really quickly, we're going to talk about what absolute value functions are. So what you should have noticed is that everything that we have been drawing is in the shape of a V. So with parabolas, we had a U-shaped, right? With absolute value, we actually have a V. So it's very sharp. There's a definite point here. Okay, and they are straight lines, whereas with your parabola you had curves. Okay, and down here we have some examples of different types of absolute value functions, and we're going to deal with a lot of these, but again, just make yourself aware. So we talked about the overall shape is going to be a V, but there's some common terms here as well. We have the vertex. The vertex is the point of the V. So whether it is opening up, like this top example, or whether it's opening down, like this bottom example, okay, that point, that sharp point there is called the vertex. Now, just like our parabolas, the left side matches the right side. It's a mirror image. So we have what's called a line of symmetry, and we've highlighted those there in green. Okay, so those are the lines of symmetry, meaning the left side reflects over that and is exactly the same as the right side. So now let's look at specifically how to write our equation. Now this first one, I've spelled out a lot of the steps for you. After that, though, I don't think we can always refer back to these steps, but we won't necessarily have to do little bit by little bit. All right, so the first step is I need to describe how the vertex has shifted from 0, 0. So it used to be here, right? But now we've gone 1, 2, 3, 4 to the left, so it's gone left 4, and my vertex is up 2. Okay, so now I'm going to go ahead and draw in. That's step 1. So we showed that the vertex used to be here in the middle. It has been shifted to the left 4, and up 2. Okay, now next I want to draw in my line of symmetry. And so the line of symmetry we talked about has to go through the vertex. So right here is that line of symmetry. Now the reason we do that is to help us identify the slope. So we're actually going to count the slope. So really what we're going to be doing here is we're focusing on the slope of the line here. So we always work with the right side. So I'm going to count the slope starting at the vertex. So if I'm looking at my slope, let's see if we can find a good color here. If I'm looking at my slope, I see a good point here, which is the vertex, and another good point here. Remember we talked about those good points are the ones that go right through the grid lines of the graph. So my slope here, I go up 1 and over 2, meaning my slope is going to be 1/2. Remember that is rise over run. All right, so now this is basically what we have, right? We know our slope is 1/2. We have our line of symmetry drawn in. So now we talked about how it moved left 4 and up 2. So let's use that to fill in. We're going to fill in, but remember, just like with parabolas, the only things we're going to replace are the a, h, and k. So we have f of x equals my a, this is actually the slope. Okay, this is my slope. So we just said the slope was 1/2. So I have 1/2. And then I have my absolute value sign. Okay, and x. Now, we are moving to the left, so that means it's going to be plus 4. Then outside of it, this is k is our up and down movement, and it went up 2, so we have to do plus 2. Now stop and think a minute, because we know how to graph these already. So does my positive slope make sense? Yeah, it does, because it's opening up. Okay, now the 1/2. Okay, that was a rise of 1 and a run of 2 here. Again, that's great. The plus 4. That means it moved to the left 4 units. 1, 2, 3, 4, good there. And then finally the plus 2 means it moved up 2 units, and we're good there. Okay, so every time we're just looking to see how does the vertex shift, and then we need to count our slope. So let's try another one. Okay, for this one here, I'm gonna look at my vertex here. I notice it went to the right 2 and up 3. It's gonna make a note of that. So right 2 and up 3. Okay, now I'm gonna draw on that line of symmetry just so I can focus on that vertex. I want to look at my slope. So I see a good point here, and actually just right here as well. So the slope of that line is a rise 1 and a run 1. So my slope is going to be 1/1, which is just the same thing as 1. Okay, so remembering, oops. So remembering our format, we have f of x equals a times the absolute value of x minus h plus k. All right, so let's write our equation. The a value here is going to be 1. That's our slope. Okay, so the a value is 1. That's our slope. Okay, then we have our absolute value sign. Oops, let me change back. We have the absolute value sign. I have x. I want the opposite of our left and right movement. So it moved right 2. There needs to be a minus 2. Close my absolute value. And then it moved up 3. So I need to add plus 3. Now, you don't necessarily have to write this 1 there. I could have just written this as f of x equals the absolute value of x minus 2 plus 3. Either way is perfectly fine, but I didn't want to leave that 1 out. I wanted to make sure you understood where my slope came from. But again, understand it was a positive a value, a positive slope, which makes sense because this graph here is opening upwards. Again, it moved to the right 2 and up 3, and I can verify that by looking at those values there. Okay, let's look at the next problem. So on your paper right now, I want you to look at the vertex. So look at that vertex and describe, write down, up, down, left, and right, how it's moved from the vertex. You have about 10 seconds to go ahead and write that down. Okay, so I can see it moved to the right 1 unit, and it moved down 1 unit. Okay, now we're going to go ahead and draw in that line of symmetry. So go ahead on your graph, sketch in that line of symmetry. Okay, now we're ready to look at, I got a little sloppy there. Okay, now we're ready to look at the slope. So on your paper, go ahead and I want you to mark 2 good points. So mark 2 good points there. I see the vertex, and then looks like this one here. So if I'm going to count my slope, I notice it went down 1, 2, 3, and over 2. So because my slope, I went down, that's going to be a -3 over 2. Now think about this. This makes sense because I have a negative slope, and when I put that in my equation, remember how that goes out front, right? That negative sign tells me that my absolute value should be opening down, which makes sense. Okay, so now writing our equation, we have f of x equals -3/2. I want my absolute values. It moved to the right 1, so that's going to be x minus 1 inside the absolute value. And then it moved down 1, so it's going to be a -1 at the end as well. All right, last one. Last one. So go ahead and mark your vertex and make a note of how it's moving up, down, left, and right. Okay, so I noticed it moved to the left 7 and it moved up 7 as well. Okay, next I'm drawing in my line of symmetry and I'm going to count my slope. So go ahead, find 2 good points and then count your slope. Okay, so I noticed my slope went down 1 and over 3. Okay, so my slope is going to be down 1, that was going to be a -1 and over 3. Okay, so when I go to write my equation, I have f of x equals, my slope was -1/3. It moved to the left 7, so in my absolute value I'm going to have x plus 7. It moved up 7, so I'm going to have plus 7 at the end.